Okay, so the next thing I want to talk about are X-linked disorders. Now, what we talked about in meiosis, which is really interesting, is that individuals, and I'm talking again from a chromosomal level, an individual that has two X chromosomes. Okay, so actually, let me go here. Okay, so an individual who has two X chromosomes, so I'll draw this, is basically, okay, so let's say you have a big A here and a little a here, and let's say this is for cystic fibrosis. Or actually, let's do something that's on that for rickets. No, not for rickets. Let's do hemophilia. Okay, so A is normal, and little a is hemo. I can't spell it. Whatever, I'll just do that. Hemo. I drank too much coffee today to think clearly. An individual that's XY, okay, has only one X chromosome and then a Y chromosome. Now the thing is with people with an XY chromosome, that Y chromosome has a gene called the SRY gene that codes for penis development, okay, or male reproductive development. So here's the deal. Now, the interesting thing is that there's only that the X and the Y chromosome are not considered homologous. They're similar enough to where they're going to pair together during meiosis, but there's no crossing over that takes place between the two. So they will not cross over. And so this basically has the SRY gene, but the X chromosome is the only one that will actually have that particular gene. So this is called hemizygous. So individuals with an X and Y, so everything, all 2,000 genes on the X chromosome, for an individual that's XY male, they're only going to get one copy of the gene, which is why it's more common for X-linked traits, X-linked meaning it's only on the X chromosome, in males, okay? And so this person has the gene for hemophilia, but the other one will mask it. But here, there's only one gene, and so that one's going to be expressed, okay? So let's go back to this. Okay, so you can go ahead and read this. For X-linked dominant traits, the allele is present, is expressed. Hypophosphatemic rickets is an X-linked dominant disease that causes rickets, a weakening of the bone due to abnormal ossification. And so we express it, X is the X chromosome, and then Y is just kind of like a placeholder. So X represents the hypophosphatemic rickets allele. Did it die again? Mm-hmm. Stop letting it die. Go charge it up. It'll come back. Charge your phone, Richie. Stop taking it off the charger. Okay, so I'm a single mom. Okay, so X to the big R represents the hypophosphatemic rickets allele, and then X to little r represents the normal allele. So answer the following questions about a cross or mating of a father who is X to the little r, Y, and a mother who is X to the big R, and then X to the little r, okay? So the genotype and the phenotype of the father is normal, because this is autosomal dominant. The genotype and phenotype of the mother has rickets. What are the potential gametes produced by the father? So just X to the R. And because there's only one X chromosome, it's not considered homozygous, or it's not considered homologous. It's considered what they call hemizygous. And a Y. And what are the potential gametes produced by the mother? X to the R, and then... It's not done yet. Just hold on. Tell me when it beeps again. X to the R, big R, and then X to the little r. And then complete the Punnett square. So this is the the egg, and this is the sperm. And when you put them all together, now this Y again is just a placeholder. It doesn't carry that gene. And so what is the predicted phenotypes of the cross described? These individuals will not have rickets, whereas these individuals will have rickets. This is more common. Again, autosomal dominant genes are not that common. The X-linked recessive traits are more likely to be expressed in males and females. And so this one is for hemophilia.
I learned how to fully unreset my phone.
Oh, great. Good job, buddy.
Thank you.
Answer the following questions about a cross or mating between a father who is X to the little HY and a mother who is a heterozygote. So he actually has hemophilia, and then this individual is a carrier for hemophilia. So what is the genotype and the phenotype of the father? So it's going to be X to the little HY, and then the genotype and the phenotype of the mother, normal. What is the potential gametes produced by the father? Are these. The potential gametes produced by the mother are these. A good way of doing it is put a comma between them, and if there's more than one, then there's going to be two. Complete a Punnett square for the cross. And so you're going to drag it down, and again, Y is a placeholder. And this individual is going to be normal. This individual is going to be normal, and then these two individuals are going to have hemophilia. These are really unique. Typically what happens in these cases is that the male is going to be normal, and then the female is going to be a carrier. That's typically what happens in this case. Okay. Okay, so we'll stop there.